Thanks for joining. So my name is Lior Cohen. I'm responsible for cloud and SDN solutions for Radware. What we've chosen to focus on today is actually our very interesting and creates a lot of interest SDN application. And because this is the fourth year of ONS, I think that the perspective I will try to give on this specific application is not only how cool the technology is, because it's very cool, but it's also how important it is and how significantly it solves a big problem of today's networks, which is a security problem. So that being said, I'll go through a few slides. I'll jump into a live demo, which is couple thousand miles away from here, so I hope it's going to work smoothly and the bitmaps aren't going to go bad on me. And then I'll just summarize with a few more slides and be happy to take any questions following that. So starting a little bit about the security problem, and this is true for either an enterprise or a non-enterprise context, but essentially one of the issues with security is that it's very high, the cost of security to start with. A port on a firewall, an IPS, a web application firewall, a DDoS protection device is an expensive port. You want to make sure you get the best out of that investment in that port, right? Additionally, the networks themselves are growing to be very complicated, and thinking of kind of private cloud, public cloud settings in which applications move around for maintenance, etc., or thinking of that applications scale out by nature of increasing their capacity and kind of being more efficient. That really means that from a networking perspective, the location of that application is really unknown. Okay, so having an attack against a certain object or a certain application means I don't know where in my network is going to be attacked. Furthermore, the attacks themselves are unknown, and we're very familiar with this. We know that around 50% of the attacks today are network volumetric, not volumetric, but network behavioral based attacks. Volumetric would be an oversimplification of the issue. And another 50% are application origin attacks. So attacks themselves are very unknown. There are all kinds of attacks, all kinds of forms, and the sizes of the attacks are unknown, and the size or the type of attack doesn't necessarily signify what the impact of this attack is. In this existing security measures, you'll put the firewall up in the perimeter or down in a certain access switch on a stick, and that's pretty much where it is. You can't instantaneously provision these capabilities throughout the entire network. Topping this off, the implication of downtime here is severe. More and more business applications are going to be running, and businesses are relying more and more on applications. So this is a pretty pessimistic picture about where we're at, and it's kind of the way it is. It's very expensive, budgets of security are tough, and really what it's all about, and really how does SDN help us with solving this problem. And this is what I'm going to talk about today, is really about a specific application that we have built, set of applications, one generally available. If you guys follow the press, we've announced it today. That helps organizations mitigate risk in a very realistic and economical manner. For showcasing this demo, I'll just go through a few basic illustrations. So I'm going to build here a very scary picture, but again, this is a very complex and interesting scenario. And I'm going to show a picture of protected networks, of which are user networks, which are data center networks or server networks for that matter. I'm illustrating it using virtual switches and virtual machines, but it can the same way be physical. An edge network through which traffic comes in and out to the different protected networks. And then we're kind of assuming that this network can be controlled by SDN controllers, some of it or all of it, the virtual elements of it, the vSwitch elements of it, as well as the physical switch elements of it. And then we're on top of this adding our SDN application. Our SDN applications includes a couple of very interesting components. First of all, it has different SDN drivers for different SDN controllers we're working with. We're currently working with the Open Daylight controller, the HP controller, the Cisco controllers, any C controller we have announced the general availability of our application today. And then it has layer 4.7 drivers, and I'll show you what these drivers are for as well. There's a set of shared services that each and every one of the applications need. And in terms of the specific defense flow this is the name of our security, SDN security applications. Specifically for the defense flow applications, we have a network anti-DoS application, which relies on our field-proven network behavioral analysis algorithms from our appliances, our Defense Pro appliances. So we've taken these algorithms and we've implemented them as an SDN application. We have an application DDoS module for defense flow, which is also applying a lot of the fuzzy logic and algorithmics that we have in our appliances as part of the SDN application and using it in a very interesting way. And then we have an APT detection module. In addition to the application itself, we're assuming that there is a set of physical appliances. In this case, we're showing our Defense Pro appliances, physical on the left, connected to this network that we can use in case of need, as well as a set of dynamically provisioned virtual DPI instances that we can effectively provision anywhere on the fly with this application in the network, wherever it makes most sense and at the scale that it makes most sense. So we can also scale this out. These DPI engines are not only automatically provisioned, but they're also fully programmable. So taking the same concepts that we have for SDN in the networking sense, we're actually applying these concepts at the application layer 4 to 7, and programming on the fly these virtual DPI engines to notify us and let us know about layer 4 to 7 behavior, and we call it app path of the network. So this is pretty much how it looks like. Important to say that the network, in terms of the demo, so when we have a protected object on the right, that there's some kind of a deviation from normal behavior, what we will do is we don't rely on the SDN as of itself to fully mitigate this attack. We will divert the traffic to purpose-built systems so they can handle this attack. And when we have rogue traffic inside the user's network, such as an APT type threat, we will block or reroute that traffic to remediation server or whatnot in that case. So these are the two functions I'm going to be showing today, both at the network and application layer. And then just to reinforce, Defense Flow Network is generally available, meaning anyone can buy this product today running on an NEC network. So this is not just lab work, this is actual production work, and the other applications are going to become available later on throughout this year. So this is important. So on to the demo. So bear with me. Oh, bitmap actually went pretty fast. So this is the UI of Defense Flow. This UI on the top, what we're seeing is a set of protected customers. We have defined, there's an option to define protected customers, add them on the fly. One customer is under attack. There's an option to, once he picks up the phone, hey, I want this protection, there's an option to automatically provision security for that customer, no problem. So on the top, we see the different protected customers. We see real-time and normal parameters for from bytes per second, packets per second, etc., as well as application parameters such as transactions per second in the middle. The way we're gaining transactions per second at this point is by VDPI engines. The way we're gaining the network statistics is actually by OpenFlow counters in real time. What I'm going to show is, first of all, launching a network DDoS attack. And by employing, let me pull this up. What I'm doing here is kind of a simple SYN flood. And what you'll see automatically is that for customer 1 on the second line here, you're going to see that the real-time counters are going up to very, very high levels, much beyond the baseline that we're building there. The baseline is kind of a multi-dimensional calculation between different parameters that we're seeing there. We're seeing that the rates are very high. The network has detected as the detector that there is an attack category in network DDoS, you see, and as soon as that is detected, it is diverted now onto these scrubbing centers. So let me show you what we're seeing here. Is actually we're seeing here that the traffic has been diverted to the scrubbing center. As soon as it's diverted to the scrubbing center, the Defense Pro appliance is actually informing the specific type of the attack and giving the security administrator a single view of exactly how this attack has been originally detected. So the network detects only suspicious traffic. this suspicious traffic is diverted onto purpose-built DDoS mitigation devices. They will define with a high certainty what the malicious traffic is. So there's a difference between suspicious traffic and malicious traffic to the point of eliminating false positives or really minimalizing them to the minimum. What we're seeing here is that at the scrubbing center is actually receiving a certain amount of traffic and only a much lesser amount of traffic, which is the good traffic, is going out of the scrubbing center. So we're only cleaning the bad traffic effectively. So this has a huge economical impact. And the huge part of this economical impact, what's so big about it, is the fact that I only need now to buy specialized purpose-built devices at the size of the attacks that I want to protect, not at the size of my entire network. Up until now, I needed to buy gear at the size of my entire network and buy purpose-built gear. So here, I only buy the gear that I need selectively in order to protect from the attacks that I may encounter, not the entire network scale. So this is pretty good. If this attack is sustained, and this is what we've seen here on the screen, the defense flow application, we'll see this is a sustained attack. Let's free up this expensive gear, as we just mentioned before, and block it at the ACL level. And in this case, we're seeing that the ACL scope is global. What does that mean? Because this is a volumetric attack, it may impact my entire network. So I want to block it as close to the source as possible. So I want to block it pretty much everywhere. So this is a global ACL scope. Pretty cool so far. So this is on the network side. Let's stop this attack and move on to the application attack. So the application attack, and we're seeing here the transaction per second counters. What it comes to address is the other 50% of the attacks that we're seeing. And we're living this day in, day out, helping our customers with our emergency response team to handle attacks in real time over multiple days. And we're seeing that about 50% of these attacks are slow attacks that go under the network radar, and you need to handle them and be able to address them only at the application level. You can only address them at the application level. One of the parameters is transactions per second, but effectively we're taking this application path and applying the same algorithmics that we are on our physical appliances at this data that we're receiving from VDPI engines. So I'm going to launch now an application attack. In this case, it's going to be a fairly simple kind of HTTP flood attack. What we're seeing here, that the counter that changes in this case is actually the transactions per second counter is changing for customer number 2. I have a delay thing here for some reason, but you're going to see that the customer 2 transaction per second counters are they're gradually growing. We're at 186. It's going to grow over 200, and once it grows over a certain number that is dynamically learned through this algorithmics, it's not something that you need to necessarily that you would hard configure, but it's a dynamic number. The attack will be detected. We're at pretty high numbers right now, and you'll see that in this case the detector that we're going to see is the DPI engine, and is not the network, because the counters are actually originated from the DPI engine, right? And very similarly, as this attack sustained, it is being diverted to the scrubbing center. The Defense Pro appliance in the scrubbing center informs the exact parameters of the attack. And the reason we're seeing here not a lot of difference between the traffic entering the scrubbing center on the bottom right hand to the traffic exiting the scrubbing center is because the volume of the attack is very low. So we're not going to see a lot of difference there. So this is really pretty cool. One of the additional interesting pieces here is that there's an option to actually automatically scale out and in the VDPI capacity based on the real-time traffic parameters. In this case as well, a sustained attack will be offloaded to the ACLs, and you'll see that in this case, because the volume of the traffic is very low, I do not need a global ACL. I don't want to put this as an ACL at the entry of the network because I'm already overloaded with the amount of flows there, and this is a relatively expensive network resource. So in this case, the ACL would be a server local ACL. I would implement the ACL as close as I want to the target, because again, having this attack flow through the network and it will not have any implications on the overall infrastructure availability. but only on the actual server availability at the end. So I will implement this ACL intelligently based on the type of attack only at the server itself. Right? So on the server I have an open vSwitch, I can implement this ACL. Again, not overloading the amount of flows that is a relatively expensive resource on my edge routers. So let's stop this attack and then move on to the last attack here, which is the APT attack. And APT is a different type of threats, right? These are typically threats that will originate from the inside of the network. You'll see an infected client, an infected user machine that will be kind of carrying this out because he connected to the internet, carrying this out from the internet. In these case of advanced persistent threats, we need to continuously monitor these suspicious networks at the application layer and really apply both, actually three things. The behavioral algorithms that we've discussed before in kind of identifying any abnormal traffic. We need to apply reputation-based, checking against reputation database, and signatures specific to APTs. So we actually perform these three things by programming dynamically DVT-PI instances throughout the network and being able to learn about these attacks. So in this case, we'll use the low orbit ion cannon attack. Pretty simple. We'll see the first time it actually goes through the network, and the network, but it goes through the network in terms of the attack has succeeded, but automatically as it's been identified by the VDPI, and we see the detectors here, the APT engines, it is automatically being blocked at the source port as close to the client as possible. Right, client local, and this would be the source port that is as close to the client as possible. And in this case, you can either do diverting the traffic or redirecting the traffic or a variety of options as supported effectively by OpenFlow. You'll see the second time I try to hit this attack, it won't go through at all. So this is pretty cool. And this is the end of the demo section. I'll just summarize here with a couple of closing remarks. So the requirement was to economically mitigate risk from unknown attacks, unknown scale, where the applications really reside in unknown locations. And that's really been the requirement. The way we're addressing it is by three main benefits or kind of innovation categories. One is the kind of matching this dynamic threat landscape with a dynamic security posture. Dynamic security posture can really identify attacks throughout the network in a unique manner by using our algorithms that are field proven on our appliances, by being able to automatically provision security capabilities throughout the network, be it virtual appliances or ACLs throughout the network, and by the ability to distribute the detection and the mitigation of the attacks in using the entire capacity of the network. So from a security standpoint, this is much more secure than what we have today. From an economical standpoint, we're dramatically reducing the cost per gigabit of protection. And this is due to the automatic provisioning of systems and only using the amount of systems that you want, as well as by the ability to selectively protect high risk and other assets in your network. And ultimately, we're also improving the overall operational overhead by this automatic ability to provision capabilities and by the ability to react to events. So economies, operations, and much better security posture. Thanks.
Thank you. So I know we're tight on time, so I'm going to ask the one question, which is, so my understanding of what you've just described here is it's not promising that it's a new attack that you're going to prevent, but it's actually driving down the costs of preventing attacks. Is that a fair assessment?
So I think that it's really a mix of these, and it is in the security world. There's no promising, first of all. So I want to just get that out of the table.
Well, let me get to the key question that I wanted to pose, which is, can you put a number on the cost reduction, be it operational or capital, that you expect to deliver?
Generally speaking, we're seeing our customers talking about more than a tenfold reduction in cost of security capabilities in their networks, while maintaining the same level of security protection or even increasing that.
Okay. Wow. Great. Thank you.
Thank you.
So I want to thank all the contestants here. This is the first time I've ever seen 5 demos that all went off well. So well done to all the contestants. And I want to remind everybody to submit your vote for SDN Idol.